This call is now being recorded. Okay. Let me make sure that I'm on the right sound option for here. Okay, that's speaker. Good. Okay. So, welcome everybody. For context, this kind of got started because I kept having people mention to me that they wanted to get into programming, but didn't really know where to start and or didn't know what class to go with, or the classes are bullshit expensive, which is a very recent thing, and I'm kind of annoyed about that because they used to be like $150 for like the entire class, and now it's like thousands apparently. So I am kind of the opinion that education should be free. Ah, wait, I think I found the button. Host controls. Um, Open. There we go. Okay, sorry, I figured that out. All right. But I'm kind of the opinion that education should be free, so that's why we're here. But yeah, welcome. This class is going to be going through pretty much the intro, the basics of Java programming and programming in general, but we're going to be using Java, which is an object-oriented programming language. If you don't know what that means, that's okay. We'll get there. Java, I think, is still the most commonly used language in the world. Python was on its tail. It may have swapped at this point. Certainly, I have seen industry use Python more and more, so it would not surprise me if they have switched. However, we're starting with Java because Python is very relaxed syntactically. So you're going to probably notice that Java is a bit of a pain in the butt to write sometimes, and that is done intentionally because it's a lot easier to move from a language that's a pain in the butt to write to a language that's easier than the reverse. So yeah, with that, let's get started on the environment setup. So for this class, we're going to be using one of the worst IDEs I have ever worked with. And we're doing that intentionally because all the modern IDEs will do half of the coding for you. And in order to learn, IDE is an integrated development environment. It's basically like Word, but for programming. So we're going to be starting with JGrasp. So if you just Google JGrasp, you're going to get to the JGrasp homepage. Do I already have this installed? No, so I will be going through this with you. Exciting. And up on the top left, you're going to see this little download link. Hello, hello. And from this download page, you're going to scroll down, and we're going to go to the one that's bundled with Java OpenJDK. So this is going to be a all-in-one installer, which is actually kind of useful because a lot of them don't do that. So just choose whichever system works for you. If you're on one of the M1 laptops, like one of the M1 Macs, you're going to need this ARM64 one. The rest of you just choose whatever works for you. So I'm on Windows, so I'm going to be choosing this exe. And so this will come with Java. I don't know what version of Java you downloaded, so just download the one here with Java. Unfortunately, there are a bunch of different versions of Java. And Oracle, who is the company that currently owns the Java compiler, or Oracle's version of the Java compiler, has changed their license about 5 or 6 years ago now, so that it is no longer free for educational use. It used to be free for all uses. Now it is no longer free for educational or enterprise use. It's only free for personal use. So we're going to be using the OpenJDK, which is basically an open source version of the Java compiler that is not bound by their stupid license. We don't like Oracle, or at least I don't. Okay, so once this is installed, yeah. I don't think she can hear you. You got to speak up. Emma says hi, Ira.
Hello.
Okay, so I'm going to choose to, I think oh, okay, fine. We can do it. Okay, fine. We can do an icebreaker in a minute. No, that's fair. I'm a little out of practice here. I haven't taught a class in 4 years. Thanks. All right. So we're gonna do. Oh no, that's the wrong one. Documents. We're gonna do this Java class. Where is Java class? HIJ. Lecture 1. Yep. All right. So while everyone's getting set up on this, we can go in a circle and do introductions. So I'll go first. My name's Cole. Hopefully you all know that. I have been in industry as a machine learning engineer for about 5 or 6 years now. I before that was teaching actually this exact class along with a couple others at UMass Amherst for about 3 years. And before that, I was a chem major. Yeah. So that's me. Let's go alphabetically, which means Ira, you're up next.
Hello, everyone. My name is Ira. What about me? I'm currently unemployed. But I've been in the industry as a software engineer for 2 years already. I pretty much went through the textbook route. I was CS major at Purdue University. Java is actually my first language. I was actually also a TA for it. And then I think during COVID, they cut down and I was no longer a TA for it. That's it.
Yeah.
Hi, everyone. Thank you.
Yeah, so she is mostly just here to observe for now. Don't freak out if you are brand new to coding. This is assuming that this class is going to be assuming that you have never coded before in your life and have never seen code. So if you have seen code or have interacted with code before, you're going to be a bit ahead of the curve, but we'll see. All right, so Himanshu's here. We'll get to him, but he's going to be effectively TAing this class. Next, alphabetically, is going to be Cherry.
Hi, my name is Sherry. I'm a management consultant, but I'm just here for vibes, and I would love to learn. So yeah, in New York and Long Island City. So hit me up if you're in the area. All right, cool.
All right, and Connie, you're next. Speak up. This is the mic.
Oh, huh. Hi everyone. I'm Connie. I'm currently an auditor at a bank. I study econ and international affairs in undergrad, but I've always been really interested in coding. So yeah, and I think this will be fun.
Yeah, and then next is I think Emma.
Okay, I'm Emma. I'm just here. I'm also fun employed now. Whoop whoop. Yeah. Sorry.
A job change.
Oh yeah, I'm going to a job change and going through a career identity crisis. So we'll see what comes of it. I'm just here.
Okay. Dakota, you're back. So it's actually your turn next alphabetically. You should have gone before Emma, but you're up. Quick intro.
Hi, I'm Dakota. I'm actually on the train right now, but that'll be great. Currently, my second point. And previously, I worked as a instructor in the advertising industry.
Awesome. And then next is EFGH. H.
Oh, hey everyone. I am Himanshu, and I took this class with Cole actually. So
5 years ago now.
Exactly 5 years ago, August of 2020 was my first lecture. So it was a phenomenal class, and like I think that it set the stage for my computer science journey. So I'm glad everyone could be here. I might be like grading, TAing, and stuff like that here. So yeah, I don't know if there is grading.
So we will be having some things that are graded, but it's mostly going to be for educational purposes. And obviously, I don't care about your final grades. Other than that, you do well and understand things. All right, Lena, you're up last. Here you go.
Hi, my name is Lena. I'm a designated bad student. I'm proud. Literally. I like to make my professor's life difficult by being absolutely a genius, but difficult in school. Wait, I wasn't done. See, already doing this. I do taxes. I do real estate taxes. And I like to be in this course because I would like to automate half the shit that I do.
All right, so now that we're done with that, is anybody having trouble getting to the screen that I am on now? This is just JGrass has been installed. Yeah, we're going back to it, man. Sorry. So I have created a little folder here just for this lecture that I'll be working through. This button goes up one level for a folder. This creates a new folder. And yeah, that's pretty much it. Please, if you're on the video call, please raise your hand now if you are having trouble getting to the screen. I'm happy to help debug. Anybody in person having trouble getting to the screen? Okay.
Were you able to figure it out? Sorry, I know that you just got that internet.
Oh, I see. Yep, internet issues, my bad. File new. If you're trying to make a new file, yeah. You mean a new folder?
Yeah. A new folder.
Yay, what do you
Oh, in person, like have discussion sessions, have office hours.
If you actually want to hold office hours, that would be kind of fire.
I mean, you might have a.
Yeah.
I mean, she's trying to do anything as a DA, by the way. So it's like, you know, like tomorrow she's leaving, and on Tuesday she's gonna go to Southeast Asia for the whole semester.
I know, we thought.
Yeah. So basically, you could become like a coal. You could become like a Hannah, like a spectrum.
All right. Are you set up?
I didn't take it.
You did, but come on, get set up.
Why don't we have
My
fun?
professor asked me a question.
All right, hey Mancho, I have a new job for you. Can you sit there and make sure she's doing shit?
Dang, sorry to say. Okay,
Sorry, we can pops.
Just put them over here.
just unplug them.
Yeah.
Is that okay?
Yeah, that's fine. Here, oh, thank you.
Whose MacBook is it?
Also mine. Porter.
Professor. You let's start from.
I've gotten that question before.
Sorry.
Yeah.
I don't know what it's called because I'm not good at this.
Yeah, so I'm using
Yeah, black one. The dark no contrast.
I'm using the dark high contrast just because it,
Okay.
well, the reason I'm using the high contrast is because it shows up better on recordings. Otherwise, it can be kind of hard to read. All right.
So you could do this one, then later you could have like thousands of to actually start everything.
Yeah,
Like,
and you can customize it.
they're
All right. So, so from here, we're gonna write our first ever program. Is everybody excited? Yeah. So, can anybody tell me the name of the program that we're gonna write? No, it's not the
Hello
programming
World.
language. What was
Oh,
that, Carrie?
Hello World.
Yes, that's correct. We're gonna be writing Hello World. Okay, so we're gonna go to File, New, Java. In the top left, there's a button called File, and then New, and then Java. So we can click this, and that's going to create a new file thing here. Hi, Jana. We just got JGrasp set up and we are about to write Hello World.
Oh, cool. Okay.
Do you have JGrasp installed already? I kind of forget.
Wait, what?
Do you have JGrasp installed, the IDE?
No, I don't have. I only have.
Okay, I will text you a link to it. Or if you just Google actually JGRASP. Like
GRESP, you said?
GRASP, like the
Okay.
letter J and then the word grasp, like to hold on to something. And then go to download. And then you want the version that's bundled with Java.
Okay.
And then once that's installed, we're going to create a new file. So this is our file. And this is where we write code. Okay, I need to make this text bigger though, so that you guys can actually see it. That's okay. So Emma is a little bit ahead of the class here, so it's okay if she's been getting private tutoring sessions, if you know what I mean, for a little while. Okay. All right. So what we're going to start off with is we're going to start by writing the word public. And for now, I just need you guys to copy what I write. Just trust me that it's correct. So we're going to go public, class, capital H, hello, capital W, world. Hello world is one word. And then we're going to do a curly brace. And you're going to see, we're going to use this a lot. It's the character to the right of the P. And it's specifically the curly one, so not the bracket. And then we're going to hit enter. And then we're going to do the closed curly bracket. And that's it for right now. And if you go to File, Save, or hit Control S or Command S, it should automatically fill hello world.java right here. If it does not, that means you've done something wrong when copying it. Is everybody able to see this? No?
I can see
Okay,
it.
so let's make a folder. Do you want spoilers or? Yeah, let's get to that when we get to that. Okay. Then go to file. Go to file. Yeah, everybody. Just wait until we get to the next slide. The next slide is where everybody's going to be asking questions. Yep, Java. And then you're just going to type exactly what I did up there. Okay, Cherry, were you able to see this as well?
Yeah, I can see it.
Okay. And Jana, are you caught up with us?
Yep.
Awesome. So now click save. Okay. So then up here, I'm also going to hit Control L or Command L to turn on line numbers. This is going to be very, very useful for us because without line numbers, it's going to be kind of annoying to for me to help you and for you to follow along with me. So I'm going to make 3 new lines here, and then we're going to write the line that is probably most confusing to every student that I teach, and you're just going to have to trust me that it's right. We're going to write public, static, void, main, open parentheses, capital S, string, brackets, space args, close parentheses, open curly brace, and then close curly brace on the next line. So this, full disclosure, is probably the most confusing single line of code that we're going to write. We will, by the end of this course, you will understand what each of these words mean. For right now, you're just going to have to trust me that it's correct. And then we can hit this little green plus up here. So this green plus is the compile button. This basically checks to make sure that our code is actually formatted correctly and is something that the computer understands. That doesn't mean it's correct, but it means that it is at least something that the computer understands. It means that the code will run. So everything inside of this main method, these curly braces here, This is where our code starts. So when I hit run, when I try to run this code, our code is going to start running from here, which on my screen is line 4. And it's going to run from top to bottom inside of this method. So right now, what we're going to do is we're going to type system with a capital S dot out dot println, and then an open parentheses, and then a quote, and we're going to type hello world. And I will explain what all of this does. We're going to kind of go bottom up here. Unfortunately, we just need to start with some high level stuff to get to the simple stuff. Yep, and then you're going to need a semicolon. So the semicolon is like the dot with a comma as well. Some people don't know what that's called, apparently. But once you've done that, go ahead and click this red running person. And you should see on the bottom, it prints hello world. And if you are seeing this, congratulations, you have completed your first program. Yeah, which is actually a question I got on my interview for Microsoft was, have you ever compiled a Java program? And I was like, I have been teaching Java classes for 3 years now. Yes, I have. Why are you asking me this? I know. Anyways, whatever. Talk about their interview hiring practices separately. Yes, Lena, what's up? Excellent question. Java is one of those languages that does not give a single shit about your spacing. I do give a shit, but for Java, you can do this. This will work. It will do exactly the same thing. It's obnoxious and I hate it, but it does work. You can also, oops. Yeah, you can also do stuff like this. This will also work. Java doesn't care. I care. We as programmers care because that is impossible to read. Yeah, other languages, okay, really only one other language actually cares. It's called Python, and we will get there when we get there, but Scala does not care because it's in the JVM. Scala is an extension of Java, basically. It is to Java as C++ is to C. All right. So what we're going to start with is we're going to talk about variables. Okay. So everything that we're going to be writing is going to be inside of this main method, right? In between what is currently lines 3 and 5, right? So we're going to start with what is a variable. So in math, we often have a function, right? Like f of x is defined as x squared, right? We've seen this a lot. We'll see like f of x, is defined as x times x, right? So in this case, in this mathematical case, x is our variable. It's any number, right? And f of x is going to be, returning the value of y as, x squared. So we have variables in programming as well. Programming came from math and thus uses a lot of the same nomenclature. But in the last 20 years, it has evolved quite a bit, and I would actually say is substantially different from math. But it's important to know that that's where it came from originally. Jana and Cherry, I just want to make sure that you guys are both able to get Hello World.
Yeah.
Okay. So from here, we're going to talk about the different types of variables. So in the f of x example, we assume that x is a number, right? There are 2 different types of numbers at a high level in programming. There are integers, which are solid numbers. Like 1, 4, 0, a million, and like, negative 17, right? Or 178, whatever. All of these are integers. There are also things called doubles. And these are things like 1.5, pi. 0.0. Negative 5 point whatever. Right? These are all doubles. That's a great question. It's because they're actually floating point numbers, but then floating point numbers take up too much space or don't use enough space in memory to store enough detail. So we had it use double the amount of memory, hence doubles. We're lazy when naming things. So don't really worry about why they're called doubles. Just accept they are for now, and we'll cover that probably in like 10 weeks, I would say. Because we're going to talk about how these are represented in binary, right? Every time you watch a movie that has coding involved, you see a bunch of ones and zeros flashing across the screen in some cinematic way, and it makes us look like cool hacker people. None of us can read that. None of us can read that at all. So, yeah, there are also things that are not just numbers that we need to represent, such as hello world. This is what's called a string. You may notice that it's a different color, and that's because we surrounded it by quotes. So we're going to have a string, and this is anything that can be represented with characters, and it's surrounded by quotes. So this would be like hello. You can have numbers inside of a string as well, but they don't act like numbers, they act like text. You can even do things like that, right? You can have emojis and whatnot in here. So it's kind of neat. Bunches of different things. We'll talk about how emojis are represented in code later. Please don't worry about that too much. It's a big pain in the butt. We'll get there. Actually, you know what? I'm not sure I will talk about that, but they're just characters. And then, speaking of characters, you also have characters. These are individual characters. Instead of being surrounded by quotes, they're surrounded by apostrophes. I do not know how to spell apostrophe. That's oh, really? I was that close? Hell yeah. So, for example, you can have 1. You can have G. You can have exclamation mark. You can even have quote, which is really confusing. Right? We also have a couple of things that you wouldn't normally think about, but we use a lot in programming, such as a Boolean. I don't know why it's called that, actually. I never bothered to learn. This has one of two values. It's either true or it's false. It cannot be anything else. Hey, Manchu, is there anything else I'm missing that I should cover right now? I think this is probably good. Okay. So I'm going to go through how to make each of these. So in Java, there are also, so variables can be other things as well. But for now, these are the default ones, the ones that we're going to be using the most. Most of these are what are known as primitives. You can think of these as like the atoms of code. It doesn't, yeah, we'll get there. But you can think of primitives as like the atoms of code, right? So they are unchanging, immutable, right? So these are going to turn purple when we refer to them as that. Hi, Michelle. Welcome.
Yay. Yay. Good to see
So
you.
just to get you caught up, we downloaded JGrasp. So if you Google JGRASP, you can download that, the version specifically bundled with OpenJDK.
Okay. That is super helpful. Thank you. Sorry about that.
Yeah.
I had something earlier that I could not move.
No, it's okay. So you're going to go to the JGrasp website. It's
Okay.
going to look like this. You're going to click download up here, and then you're going to click whichever of these, the version bundled with Java, OpenJDK, whatever. Okay. So far, just based on what we have, does anybody have any questions with the types of variables that I've covered? And please don't be afraid to ask questions, because odds are if you have a question, somebody else has a question as well. Pretty much. These are different types of data that programming languages can hold, right? So we as humans, you know, if I tell you my name is Cole and my age is 26, right? And the statement I do like ice cream is true, right? That is you're storing all that information the exact same way. But in a computer, we have to be a little bit more finicky about how we store some types of data, which is why we have these different types, because we have to treat them differently. One example I will show you soon comes with how we add things. Okay, so pretty much, yeah. That's actually how it's stored underneath the hood. It's either a 1 or a 0, but yes, it's true or false. It can only hold those two values. Yeah, characters can hold any single character that you can type on a keyboard and a bunch of characters that you can't type on a keyboard. Like backspace, for example, is a character that you can hold, which is really interesting and weird, but whatever. Strings can hold a whole bunch of characters. That's literally what they are, is they're just a bunch of characters put together. Doubles are any number with a decimal, and an integer is any number without a decimal. There's an asterisk on those, but we'll get to that eventually.
Matter if the after lot like does it matter?
So the question is, does capitalization matter? The answer is yes, in most cases. So anything that is main is special, in my opinion, should be purple, but whatever. Anything that is already defined, you just need to reference it by name. So for I'll give you an example. We're going to create a quick int variable, which I'm going to call number. And we're going to set it equal to 5, right? And so this is how we create an int variable. Now, whether I call this number with lowercase or number with a capital doesn't really matter, except for the fact that it's convention that we use lowercase for variables. But the program would work if it were all caps as well, too. It's just, it means something different. But this is how we make an int, And much in the same way that we can system.out.print hello world, we can also system.out.print our number. And if we run this, we're going to get the number 5 printed out, because this is what's called a variable. And when it sees number, it's going to try and find the value of number, which is currently set to 5. So there's a couple of different parts of creating any variable. There is the declaration and there is the instantiation. So the declaration is where I say, int number. And then this is the instantiation. So this is declaration, and this is instantiation. I hope I spelled that correctly. Instantiation, thank you. Okay. Now, at a high level, what this is doing is this is basically creating a box in the computer's memory. You can think of memory as a desk. Okay? So on your desk is where we're going to be doing work. And I'm going to tell you, hey, I need you to hold a number. So I need you to make enough space on the desk that we can put a number. That's what this declaration is. And I want you to call that space number. But I need you to make enough space to hold an int. And we're going to call the space that you make number. Then on the next line, I tell you, hey, that space that we said for number, we're going to give it an initial value of 5. So that's declaration and instantiation. You can also do that in one line. Which is what I started with. Any questions on this so far? For those of you who haven't seen code before, I expect you to have a lot of questions. So please do pause me as we're going.
So you can't just have declarations on a phone, right? It always needs to come with.
So you can have a declaration, but if you declare a variable and never give it a value, you can't use it. So there's no real point in having the declaration without giving it some value, right? Now you can have the declaration early on in your code, even though you don't initialize it to way later. But at some point, you're going to need to declare it. The point of the declaration is to tell the computer and the compiler what type this variable is, right? So anyone here who's programmed in Python but not Java before, you might be confused on why we have to say int number at all. Python doesn't handle types. It is what is called a dynamically typed language. We're not going to get into that until the next class for those of you who are taking the Python version. But for Java, we have to give all of our variables a type. So we're declaring a int, which is short for integer, called number. And this could be called whatever you want. You could call it potato. It doesn't matter. This is entirely up to you. As long as you refer to it. Oh, yeah, you're right. I missed one. As long as you refer to it the same, you'll have no problem. But you'll notice here that I tried to assign number to 5, right? When the code was like this, and it didn't know what number was, so it didn't like that. But yeah, it doesn't matter what you call it. It just needs to be consistent, that's all. Oh yeah, sorry, I should have mentioned that. Thank you. Good point. So the way I've been making these comments here is with // I probably should have mentioned that before.
So like the it doesn't see that.
Yeah.
But it's for your own.
Yeah. Sorry about that. I definitely should have mentioned that. My apologies. As I mentioned, I'm a little out of practice, but I'll get back into it soon, don't worry. But yeah, so the // everything after that is on the same line is going to be a comment. This is what's called an inline comment. Okay, so the computer will ignore this.
Okay. I did another slide.
So this is where I'm telling you to make room on your desk for an integer, right? Like clear off a section of your desk, like draw a Sharpie or paint or tape or whatever, and we're going to call that space number, but it needs to be enough space for an int. Does that make sense? No? Okay, so the table is what I'm using as the analogy for a computer's memory. So a computer has memory, which if you're on Windows, you can actually see your memory by hitting Control-Shift-Escape and then clicking this performance bar on the left side and going to memory. And you can see that I have 31.1 gigabytes of memory and I'm using 17.6. What the hell? All right, whatever. But yeah, I don't even know. But the point is, this is what memory is. And we need to be using memory when we're running programs because our program actually runs in memory. So what I need to do is I need to tell it to make some space in the memory for a number, an int, that we're going to call number. Does that make a little bit more sense? And then I'm telling it that we're going to put the actual value of 5 into that spot. Does that make sense? Oh, that was showing that you can do the declaration and instantiation on one line. No, because you can't have two variables of the same name. The question, by the way, because I know the mic is a little quiet because I don't have a proper setup for a classroom, is shouldn't this be number instead of number 2? The problem is if I try to do that, it'll get confused because now I'm telling it to make 2 sections in memory and refer to them by the same name. And it's going to say that's a problem because it's already defined, right? We already defined number up here, so we can't define it again. Which is why I called it number 2. I can see we're getting a little bit confused. Does anybody else have questions before I? Yeah, go for it.
Like, what if we don't write that?
Yeah, I see. So the question here is, what is the point of the system.out.println syntax on line 16 here and line 4? What if we don't put that? So the point of this is to tell it to actually take that value and write it to the console. This is the console down here. If we don't have this, at no point will it actually write it out. So if I just put number, for example, this isn't an instruction. This is basically just saying 5. 5 is not an instruction, right? What I want is write 5 to the console. That's effectively what this is saying. System.out is the console. Print line means write out whatever I'm going to say. And then number. So we will cover how this works a little bit more in detail, but for now, just accept the fact that this is print. Okay, Gia, Cherry, Jana, and Michelle, do you have any questions?
Nope, I'm good.
No questions.
I'm good. I like studied CS in college, so
Oh,
actually
okay.
I'm
So
kind of familiar. Yeah, I'm kind of familiar with this, but I
Okay,
can help
cool.
answer.
Sure.
I can help answer
And-
anything if people want.
Fantastic. Gia, anything from you? Okay, she might be AFK. That's okay. All right. Are you helped?
Yes.
Okay. So you might notice that I called these variables. Now, what are some cool properties of variables? The main one and the most important one is that they can change. So we can print number, and then we can actually set number equal to 17 or anything else. And if we print it again, so notice how I don't have the word int in front of it. I'm not creating a new variable. I am referencing the existing variable and changing its value to 17. So then I'm going to print this value. And can anybody predict what this is going to print?
17.
Right. So it'll print hello world from here, from line 4. Then it'll print 5 because at the time of this print statement running, number is still equal to 5 because we haven't updated it yet. Then we update it to 17 and then it prints again and it's now 17. So it's important to remember that the program runs top to bottom. It doesn't look at the eventual number or value of number and then print it here. It only knows what it has figured out so far.
Wait, sorry, could you remind me what the int number 2 is compared to
Oh,
just
that was just me. That was me just showing that you can make it in one line. I
Oh.
can delete this if it's confusing people.
but int number 2 can be like any number, not 5, right?
Yeah, it could be anything you want. Yeah, you know what? I think you're right. I'll just call it potato. Thank you.
Sounds good.
Yeah, I have a tendency to name my variables somewhat ridiculous things, which is not really a good practice, but I guess in this one particular instance, it's a little bit less confusing. So that's fair. That's fair. But yeah, I'm just calling it number. We can call it even. We can make it -5. How's that? All right. So this is examples of how we can work with numbers. So we can actually do some really cool things, right? So for example, down here we do int num1 equals let's do 10, and then we do int num2 equals 15. Oops, I need a semicolon at the end of that. So you'll notice that we're ending a lot of our almost all of our statements in semicolons, and this is basically just the period for programming. And then if we system.out.print print line, actually we can do int num3 equals num1 plus num2. If we print line num3, can anybody tell me what this is going to print? 25, right? And that's it. This is how we work with ints. So already you can see that we can do a handful of neat things with integers. So we can do. Hold on, I hear that. I'm coming back. Don't worry. Yeah, we're gonna get there. All right. So, can anybody tell me? Oops, I broke that. Can anybody tell me what this is gonna print? Oh, let me get rid of that. What is line 22 gonna print? 25, right. What is line 23 gonna print? Yeah, -5, right. What is line 24 gonna print? 150, right. And what is line 25 gonna print? What? Yeah, so that one's gonna surprise you.
0.
It's actually gonna be 0. So first, before we get to so because that's actually a really good thought, and you're correct. It's because this is num1 is an integer and num2 is an integer. All of these operations between two integers must result in an integer. Thus, when we do 10 divided by 15, right, we should get 0.66666 repeating.
And it's secret doubles.
Excellent question. Let's try that. Ta-da! So you're absolutely correct. Great insight. But yeah, so doubles are capable of being of having integer-like values, not technically integers, but we'll get to that later. But yes, they can actually hold these values. And the way that programming languages, not just Java, this is shared. I think this might be the only thing that is truly common between every programming language, which is kind of cool, is how they handle the conversion of a decimal number to, or a float or a double to an integer. And you might notice it doesn't round. When these were ints, it didn't round to 1. It went to 0. So it does what's called truncation, which is basically where it chops off everything after the decimal point. So it just chops it off. I mean, so basically, yeah. So you can technically, so the way that you can mathematically think of it is it will always round towards 0. I like to think of it as it just chops off everything after the decimal.
So the resulting answer is 1.
Yep. Yeah, and feel free to mess around with this on your own as well. You know, we do all have computers in front of us, and that's kind of the point. You don't need to follow along word for word with what I'm doing in class. Yes.
Number is 5, and then number was 17 without the integer. It doesn't create an error in thinking that number is 5 and 17.
Say that again. Sorry.
So like the original line item, like from line 12
Yeah.
to line 13,
Yes.
like 18, right? So ultimately, like when the computer right now, if you're saying print number, is it going to be printing as 5 or 17?
So it depends on where we are in the program. So if I'm going to show you the debugger here, it's not important how it works, but take a look on the left side. You can actually see all the variables we're going to have down here. So you can see that number is 5. We just ran line 13. We're about to run line 15.
Yeah.
Right? So we're about to run line 16. It's going to print number. What is number?
5.
Right. So it's going to print 5. You can see that just printed down 5.
Yeah.
We're about to run line 17. So we're going to update the value of number to 17. So then we do that. And you can see it turned red because it changed. We're then about to print it again. What's it going to print? Right. And so this is my point when I say that it runs from top to bottom. It literally does run from top to bottom. It's not predicting anything. The computer is very, very dumb. And this is actually something important that I want to mention because a lot of people get confused. The computer cannot read your mind. It cannot see the future. It is actually very, very, very stupid. A very common lecture that I actually used to do in 121 back when we had them in person was I would have my students try and tell me how to make a peanut butter and jelly sandwich, right? So if you try to describe to me how to make a peanut butter and jelly sandwich, what are you going to say? How do I make a peanut butter and jelly sandwich? Give me the instructions to make a peanut butter and jelly sandwich. What do I do? Get the ingredients. How? Okay, so I've got the ingredients on the table. What do I do? So you want me to open it up. So I'm going to take the jar and I'm going to smash it against the table. Now the jar is open. Oh, open the lid. Okay, so I take a drill and I drill through the top of the lid. Right. So the point is, right, you need to grab the lid with your right hand, grab the jar with your left hand, rotate the lid counterclockwise on the jar. Right, exactly. It's all programming languages. They're all stupid. There are different levels of stupid, but they're all stupid. All because they get smarter because we write them. We write the code that makes them smarter. But I think you're going to realize that them being stupid is intentional. When we're talking to people, right? Sometimes they misunderstand us. You know, you will think I'm talking about one thing when I'm actually talking about something else, or you'll hear the way I said something and think it was rude, but I didn't mean for it to be rude. I just meant for it to be, whatever. It's polite in my culture, whatever it is, right? And that's because we have linguistical differences, or there's room for interpretation and vagueness in our language. The thing with computers is that there can be no room for vagueness. We want this to run exactly the same way every single time, no matter what computer it's run on. The program will run exactly the same way. And so to do that, we have to be extraordinarily explicit in our instructions. Very, very, very clear. Because the computer is too dumb to figure it out. And even if it were smart enough, it might not figure it out the way that we want it to figure out. So right now, if the computer ever does something I don't understand, I can just dive into the code more and I can eventually find the instructions explaining why it did that thing that way. Yeah. Right? For example, if I have a section of code down at the bottom that prints 42, and I ask you, why does it print 42? You're going to look at the variable that it's printing, see where that variable is set, what operations have been performed on that.
Is there
In fancier IDEs, yes. In JGrass.
Okay.
Not JGrass, but yes, in fancier IDEs, like for example, this is VS Code, this is a different IDE. This is also Python, which is a different programming language. But for example, if I open some section of code and I have some variable like client here, I can right click this and I can see go to definition. And it brings me up here, which is where I define that. So we're not gonna get into Python, but just to show you that there are other IDEs that do fancier things. We are intentionally using a dumb one to give you practice doing it yourself. Because it'll also force you to write good code, because otherwise you won't be able to read your code. And Himanshu, as somebody in the field, I think you can understand how important having properly written code is on interviews, especially. You will not get a job if you write sloppy code. All right. Right, exactly. So these are this is our example with ints, and I showed you just doubles now. So we can also do strings, right? Strings are a little bit weird, right? So we had string, I'm going to call it str, or yeah. I'll set it equal to hello world, exclamation mark. So this is our string, right? And we can do we can system.out.print line start, right? And we will print. Great question. I'm so glad you asked. Why is string white and int and double? For example, we have int, we also have, double. We have, yeah, we'll do. Is it really? I didn't know that. Huh. Well, there you go.
What's the color?
So, it changes depending on the IDE, but string in JGrasp on my setup, for example, green is for strings and characters, and then purple is for what are called reserved words, which is any word that you can't name your variable this. For example, you can't name your variable int, or static, or void, or class. You're just not allowed to do that. Like if I try and do, int, or like int double equals, 4, it's going to get really mad at me. Oh, you just have to make this not called double, right? I can't call it public either, right? Any purple value or any purple word that's called a reserved word can't be used as the name of a variable. And you can see it's just getting really confused.
Is that the same in other IDs?
So int, char, double, boolean, all of those words are what are called primitives, right? That's what I discussed earlier. That's the sort of the atoms of code. You may notice that a string is just a whole bunch of characters put together, right? Thus, a string can't be an atom because you can break it into smaller pieces, right? A character cannot be broken into smaller pieces. That it just is, right? A string is a whole bunch of characters. A character is just a character. It doesn't get simpler than that. That's basically the way you can think of it. So the primitive types that we are mostly going to be working with are int, char, double, boolean. There are also primitives for float and it is for languages that have primitives. I believe the primitives are identical to all programming languages. If not, they're very, very, very close. Because I can tell you that like C, C++, Scala, all have int, char, double, boolean, float as primitives. In Python, there are no primitives. Like there are, but there aren't. It's confusing. What? I don't think so, no. I mean, it's a reserved, so there are reserved words in Python, but not primitives. But these types exist, if that's your question. And they are typically treated the same. What do you mean? Documentation. Yeah, so these characters, like if you had never coded before, are you asking how you'd come up with this? Basically a class, right? There's some documentation that's not for us. That's a DoorDash or something. Sorry, somebody's at my door. So this would just be something you learn in a class. It's sort of like asking, as a newbie for French, how do I learn to speak French? Right? Ultimately, you just need a class to tell you how to speak French. There are certain parts where you need a reference, right? And there are code references for it, like a dictionary would be in French. If you're just trying to find like the list of all primitives in Java, honestly, the way that I would do that is like all primitives in Java. And then there's probably going to be some Oracle Help Center, article for it. Is it okay? So this is all of them. We've got byte, short, int, long, float, double, char. String is not a primitive. This is wrong. Yeah, this is wrong. This is claiming it's a primitive. Oh yeah, you're right. You're right. Oh yeah, you're right. It's not okay. This is the list of primitives. My bad. Yeah. Well, so those are reserved words versus primitives. So primitives are only data types. There's reserved words. Every primitive is also a reserved word. But yes, these are reserved words as well. Don't worry about that too much. The primitives are what we care about. I think it is actually. Yeah, not primitive, but it is a reserved word. It's just like class or interface. It's a reserved word if it's purple. Some of the reserved words are primitive, which is why they're reserved. Sorry, that's a little confusing. Don't worry too much about the reserved words. Just focus on the primitives, right? So int, char, boolean, double, right? Stuff like that. You can't use outside of where they're supposed to be used. It basically just means that you can't call a variable static.
Yeah.
Great example.
Yeah. These are like basis.
Yeah, the atoms. They build everything is built on top of them. They're the building blocks of the rest of code. That's a good way of putting it. Yeah. Yep.
So in line 30 system period out to like what is the period?
So the period is not the period of coding, right? The semicolon is the period of coding, but the period is actually not really. It's a little bit confusing. I'm going to ask you to put that question on hold, and we'll get back to it probably next week when we start talking about honey. Hit end. Hit end. Hit end. You have an infinite loop. Sorry, Emma's working on a personal project and is a little bit farther ahead of this class. She's probably about on week 6 for us. Yeah, I know. She's been zooming, but she's also been on and off doing this for like a year. So we're getting there. But yeah, ask next week. Well, if you won't even need to, because I will cover it more specifically. But so let's continue with this. So this is a string. String is made up of a bunch of characters. And in fact, you can even see that when I use the debugger, right? And I look at, oh, sorry. I have a, oh, oops. So if I actually look at the string here, yeah, I think a couple of people are trying to grab food after this. Probably about 45 minutes. I don't know. Around here somewhere. Maybe.
So if I have wrote summary for them, unfortunately.
Sure.
You know summary?
Oh, you gotta wake
Yeah.
up.
Right.
Oh, yeah. That's not nice.
All right. Let's hold it together for just like 30 more minutes. If I can get through the rest of these data types and the operations on them, we'll be good. All right. So anyways, what I was just trying to show here is you can literally see that this string. So you'll notice that the rest of these types, I can't expand at all, right? There's nothing else to say about a Boolean except for the fact that it is a Boolean or a character or num1, num2, right? These are just ints. But this is a string, and there's a whole lot more to say about this string, right? What type of string is it? Is it a compact string? What type of characters are being stored in here? And then the actual characters, right? Now, if we look at the actual characters, these are just a bytes, right? Nothing smaller than that. So that's just to show you, but don't worry about that. But that's why this is not purple, is because it's not a primitive. It is an object and not a primitive. So turns out that doesn't actually affect all that much for right now. We'll get into the details a little bit more later, but this is our string hello world, and we can print it, right? And we'll notice that it prints hello world. I'm also just gonna system.out.println string things now. And this is just to separate it in our console output so you can keep track of where we are. Okay. Yeah. Yeah, there is what's called a language specification that is not very readable unless you are already very familiar with programming, unfortunately. But it basically says, you know, starting out from a blank file, what are the possible words that you're allowed to put there? Turns out in Java, there's only 3. There is import, public. Oh no, sorry, there's 5. There's import, public, private, package, or whatever. It's protected. It's not. I don't think a class can be protected, actually.
But you could do like something that refers somewhere.
Yeah, but I don't think that can be the first class. Yeah, it's whatever. It's not important. Right. We can debate that later. But yeah, there is a language specification, but it's not going to be very useful to you.
It's like actually reading a French dictionary teaches nothing about.
Right. That's basically the analogy. Yeah. In the same way that when you're learning a language, there is a dictionary, but there's not like a universal guide on how to write sentences. Yeah. You just kind of have to pick it up. It is a language in that sense. So we have our strings, right? And we can do things with strings as well. For example, if I have, you know, stir1, which is hello world, and I have stir2, which is hello world, right? Or actually, we can just make this one world, and we'll make the first one hello. Yep.
Right now, if you were to run this, it should be an error. Right?
What do you mean? Like right now? Yeah, because that variable does not exist. That's correct. Yeah. So if we try to run this, it'll say it can't find the symbol because stir has never been declared anywhere. So if I put stir1, oops, sorry, this will work. And I can even do something like this. What do you think this is going to print? Right, it is going to print hello world, but you might notice with the exclamation mark, but there's no space because neither of these strings have a space. And so it's literally just smushing them together. Like this? Yes, that works. That totally works. Now, what if I do something like this, where I set stir1 equal to 10 and stir2 equal to 15? What do you think this is going to print? Come on, guys, this is basic math. What's it going to print? You think it's going to print 1015? You're correct. It will print 1015 because remember how I said earlier, the reason that we need to have this type in front of it is because we treat the data differently. If it's a string, the way that we add is by concatenating.
Yeah, this is data type of that right now. It's not a number. Just like
it's just a string. It's just a word that contains only numbers. Right. Yep. That's it. So that can be kind of confusing. Now I'll give you a real fun one. Back up here, where we have the empty string plus 20, the int 20 plus the int 15. What is that going to be? Think about your order of operations. So previously it was 35. What do you think it'll be now? Anybody on the phone have any suggestions? Cherry, Jana, Gia? What was that, Cherry? I couldn't hear you.
Oh, that was nothing.
Okay, so keep in mind our order of operations. If I told you that you had a string and it's empty, but it's still a string, and you need to add the number 20 to it, how might you do that? It's okay if you can't think of it because it's a little weird. So this is going to create the string 20. If you add a number to a string, it converts the number to a string and then adds it. So given that, what do you think this is going to print? Yeah, exactly. This is going to print the year before it all went to shit, 2015. Right? So it's important to keep track of what our types are. Now, actually, let me go back here. Or what if I did parentheses? Because programming does follow order of operations. So now, what is this? What data type is this? Right, and what data type is this? So if you add two ints together, you're going to get a. And then this is a. And this is a. So you're going to add them together, you're going to get a. Right, but it's going to be basically the same value. But you're right, it will actually be the string 35. Think about order of operations. Would that make a difference? What gets added first here? Yep, so this is an int, which means it's going to be a. And then this is an int, and this is a string, so it's going to be a. It's a string, but it's still 35. Because the int addition already happened, right? We go left to right in order of operations, right?
Yeah.
PEMDAS. So it's going to do num1 plus num2. Those are both strings, or both ints. So it's doing 15 plus 20 gets 35. And then it goes the number 35, like the int 35 plus an empty string is going to be the string 35. And so it then prints the string 35. Yeah, if you do subtraction, I think that's an error, right? I think every other type, some languages allow multiplication of strings, which is a little weird. Java does not, but like for Python, if I do, no. So Python, for example, if I do this, if I made this hello, and I tried to multiply the string hello by 5, in Python, what that will do is it will print hello, 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 hello.
Okay.
Right? Right. So in Python, I can do this. Right? But Java does not. To Java, this is weird.
Add space plus string times 5.
If I wanted to add a space between it, and I already closed it. But if I wanted to add a space, I would just have the string be hello space. Right. But yeah, I'm going to try and avoid bringing up Python outside of just when it's slightly different. And that's just because a lot of people and a lot of you guys in this class are going to be learning both at some point. So, yeah. Okay. So this is strings. You can add them, but you can't really do much else to them. However, because strings are objects, you can do a couple of other fancy things. So strings are objects. Objects typically, but not always, have methods. Okay. One of the methods of our object, of our string object, is toUpperCase. And the way that we invoke a method is period. So if we do str1 dot toUpperCase, and I run this is going to print hello in uppercase. And what it's doing is this is a string object, and objects have fancy things that we can do to them. If this is going over your head, don't worry about it. We're going to cover it in a lot more detail next week. We'll cover why that's a period next week, right? But there's a couple of other ones. I think does Java have reverse? No, it doesn't. That's okay. Yeah, what is it? Yeah. Yeah. Oh, you need to use the string builder, stupid ass. Yeah, don't. I told you Java is intentionally obnoxious with a lot of its stuff. But I'm not even going to get into it. We're going to cover that later. But yes, the way that I would personally reverse a string in Java is going to be using what's called a loop, which I will write here, and we'll cover what it's doing later. So that's then stir1 dot length. It is length, but it's a method, and then I plus plus, and we're going to system dot out dot print stir1 dot char at I. Oh no. Yeah, you're right. Stir1 dot length -1 while it's actually greater than 0 or equal to 0. Char I, and then system dot out dot ln. This is how I would do it. Ah, well, apparently not quite. 5 out of bounds, huh?
Oh, because
That is greater than or equal to 0. It's saying 5 is out of bounds. I think I just needed parentheses there. I think that's all. What? Why is that happening? Oh, because it's I plus plus. Yeah, my bad. Sorry. There we go. Hola. I reversed the string here. Yep. Well, it's basically just reversing the string, right? So for example, if I reverse race car, right, we're going to get whatever race car is backwards. So we're going to talk, yeah, so I was actually going to start loops today anyways. So there are two types of loops in most programming languages, including Java. There is a while loop and a for loop. A while loop takes a condition and it will continuously loop between the two curly braces afterwards while this is true, right? Loops forever as long as condition is true. So for example, if I have while num2 equals 15. So remember how a single equals is an assignment? Double equals is a comparison. Okay. So while this is equal to 15, we can system dot out dot print line, num2 is 15. And if I run this code, can anybody tell me what's going to happen? So Emma, can you repeat that a little louder?
Oh, it just goes on.
What just goes on?
Num2 is 15. Num2 is 15.
Right, it's going to keep printing num2 is 15 forever. So yeah, so it's going to keep printing num2 is 15 as fast as it can forever. So that's where we need this button here. This is the end button. It just means stop. If we know you didn't get to the end of the program, but just stop. Right? So this will continuously run as long as num2 is 15. Now what I can do is I can say while num2 is less than 25, right? We can print num2 is plus the value of num2 and then an exclamation mark. And then what we can do is we can have num2 equal num2 plus 1. So what this means is that we're going to take the value of num2 and we're going to set it equal to the current value of num2 plus 1. So the first time this runs, So follow along. Num2 is over here. I'll just leave it there.
15 only for 20.
So it will print. So it'll print num2 is 15, and then it's going to take the value of num2 and set it equal to num2 plus 1, right? So num2 is now equal to 15 plus 1, which is 16. 16, so that it then hits the end of the loop and it goes and it checks this condition. And because that is less than 25, it prints that, and it will keep doing this, as Lena said, until we print 24, because it's now going to add 1 to num2 and set it equal to 25. It's then going to go up and check if it's less than 25. 25 is not less than 25, so it will exit the loop, and we'll go to the rest of the program. Right?
Num2++.
Yes. So there are a handful of different shorthand ways to write this. Other ways to write this would be num2 plus equals 1. That's just a faster way of writing num2 equals num2 plus 1. And then because we're specifically adding 1 to num2, we can just do this. Yeah, plus plus for whatever reason just means add 1 to num2. I don't know why. They just, and that shortcut actually does not exist in Python.
Right.
This one does. The one on line 39 exists in every programming language I'm aware of.
Yeah, what is the num2++1? Why not?
That just means you're adding whatever value. Yeah, because it's literally just a faster way to write this. These two are exactly equivalent. That was subtract 1. Yep. You can do times equals, you can do divided by equals, and you can do minus equals, and you can do plus equals. Yeah, it doesn't have to be 1. It can be, it could be whatever. It could be 78. It just means that, num2 plus equals, num2 plus equals is the exact same as writing num2 equals num2 plus. And then whatever you put after that is fine. Right? That's all. I write it out like this just so people see it, and understand it. Remember what I said about spaces, right? Java does not care. Right? So if I write it like this, perfectly valid. I find that illegible. I can't read that. So I like having the spaces. Most people typically will put spaces around operators and definitely assignments. Yeah, it's really hard to see.
It's plus equals 1, but not base plus.
Because plus plus is what's called a unary operator, like -5. It's not operating on 2 entities. It only operates on a single entity. So like if I have A plus B, right? Plus is a binary operator.
Yeah.
So it requires something on the left and something on the right. A minus B, in that case, minus is a binary operator, requires 2. You can also have +5, like just written down. If I just write +5, that's signifying that it is a positive integer 5. That in that case, plus is a unary operator. It only needs 1 number. It's nothing on the left. Likewise, -5 would be a unary operator. It's nothing on the left. Plus plus is also a unary operator. It doesn't have anything to the right of it. It only operates on num2. And so with unary operators, we typically don't put a space. Does that make sense? So like up here when I did -5, right, I didn't put a space there either.
Yeah.
I could, right? So if this makes sense to you, this should also, because they're basically the same thing. They're both operators that are only acting on 1 number.
But that means exactly the same as. Wait, what is the plus plus?
Add 1 to num2. All 3 of these have the same outcome.
Gotcha.
Now, if you end up getting, Yeah, if you end up getting really into programming, you're eventually going to learn that technically all three of these are slightly different, but for applications that we will not be talking about at any point in this course. Oh yeah, there's also, yeah, I forgot. Yeah, there's also,
It's the same thing but different.
they're all the same thing. They will all add 1 to num2. For our purposes, for this class, they are exactly the same. And Himanshu, we're not going to talk about the differences. They have
Technically,
slight
they're different.
they have slight differences that do not matter for the vast majority of instances. Like,
the way that fun.
yeah, so the way, yeah,
Logic of the way it's running.
yeah,
Got it. Yeah.
Yeah.
Okay. Got it.
yeah. So don't worry about it. No.
Those also.
Yes, because this is atomic, actually. Again, we're not going to talk about this. We're not gonna talk about Yeah, this one is only relevant in multi-threading. But yeah, but it's really not relevant for this class. So anyways, so this is a while loop, right? It will continue to run while this condition is true. And it's very easy in while loops to have an infinite loop by mistake. We often use while loops as well for any type of loop where we don't know when we want it to end. For example, if I'm trying to write a piece of software that adds 2 numbers together, and I'm asking the user to enter in 2 numbers, and the user is being a little dipshit, and the user writes potato, princess, unicorn, 5. I don't know how many times they're going to be a dipshit. I don't know if I need to keep trying again while the user input is invalid, right? So I'm going to say, like, while user input is invalid, right? Keep asking the user for a number. And eventually we're going to get a number, and then we can move on. Does that make sense?
Your phone number, but you cannot just say your name. They have a
Right. Right. And so if you put the wrong information, it tells you to try again. Right? Or like with a CAPTCHA, for example, if you mess up the CAPTCHA, it'll be like try again. So in that case, it has a loop in there, right? While, user did not pass the CAPTCHA, try to get the user to pass the CAPTCHA.
The while. There's no formatting. Like,
The while loop, it's conditional looping. So it's not formatting, but it is looping. A for loop can technically be used as a while loop. A for loop has 3 parts. Okay. So it has I'm going to do this in a comment first, actually. For run at beginning, semicolon, condition, semicolon, run at end of every loop. Okay? This is how a for loop works. So very often you're going to see something like for int I equals 0, while I is less than stir 1 dot length I plus plus, which we already discussed is the same as saying I plus equals 1. So what this means that's a multi-line comment. You can ignore that. But what this means is we are going to create an integer at the beginning of this loop called I, and we're going to set it equal to 0. We're going to keep running this loop while I is less than stir1 dot length, which is just going to be the length of whatever this string is. So this is race car, which has a length of 1, 2, 3, 4, 5, 6, 7. So this is just going to be 7, right? And then I plus plus means at the end of the loop here, we're going to add 1 to I. So this is basically almost exactly the same as writing Almost the same as that. Functionally, it is the same. Do you understand why that makes sense? Because this first section, we only run at the beginning of the loop. We are creating a new int called I, is setting it equal to 0. Likewise, we're just creating this at the beginning. This is the condition.
Yeah.
Right?
Yeah.
That's the condition, same thing. And then at the end of every loop, we're going to run this. So at the end of every loop, we just put that. Right? So for example, if our code is print, what is it? Stir1 dot char at, which is the character at position I. Right? Oh, sorry, it's not print. In this language, it's system.out.print. In this case, we don't want line because line, well, actually, yeah, I'll do line. Line adds a new line at the end of it. But sure, we can put one in. Right, so if I do this, these two loops are going to do basically the same thing. Ah, what do we have? Can't find stir1. What? Oh, it's not cat, it's care. Right? So it prints race car, right? Because these are doing the same thing. And we can even see that if we enter the debugger. Right? So stir1 is race car. And if we step down, we now have an int I that's equal to 0, right? While I is less than stir1.length. So stir1.length is going to be 7. 0 is less than 7, so we enter. We're going to print R, and then we're going to add 1 to I, and in the same step, check if it's less than 7, which it is, right? So then we enter the loop. I is now 1. I should mention, by the way, if you're wondering what char at is doing, it's because strings are 0 indexed. So the actual indices of race car, this is 0, 1, 2, 3, 4, 5, 6. Right. Everything in programming is 0 indexed. So the char at 1, the air quotes first character in race car is actually A. We refer to R as the 0th character. And this makes math pretty easy. It actually helps with us. It helps us in a lot of ways while doing coding. But just accept that it's 0 indexed. Everything is 0 indexed. It's not just strings. But so now we're going to get the first character, which is going to be A. And then our, we're going to increase I by 1, right? And we're going to, oh, hold on, it's fucked up because I edited the code while it was running. Sorry, let me try that again. Okay, so we're going to print A, and then I will be equal to 2 now, and it will then check if that's less than 7, which it is. So we're going to print the second character, which is C, right? And keep going. Any questions on this? No? Okay. You can also be really lazy, and if you don't ever want to write a while loop, you can do this. Technically, exactly the same as a while loop. Yeah, because you're just leaving the do at the end of every loop and the run at the beginning blank and just doing the condition. Same as a while loop. But anyways, okay. I think that's all I actually want to dive into today. We have char at, which gets an individual character from a string, right? We've learned how to add numbers and increment numbers. We've learned what the different types of primitives are and how to work with them. So we'll get to that later. I think that's a good one, but for later. But yeah, any questions on anything today? Now's your time to ask questions. If not, we can all go get food, and I'll see you all next week. Yeah, go for it. Great question, actually. So the curly brace denotes scope. So anything inside of these two curly braces, for example, is inside the for loop. Anything inside these two is inside the while loop. So all of this code will get looped. Right? All of this code will get looped. It's okay. Inside for things like a loop, yes. Likewise, our main method is everything between this curly brace up here and the one down on line 58. Right? So all of this is the main method.
Technically, everything is set up.
Yeah. And then this one, down to 60, this is all part of the class Hello World. We'll cover what a class is later, but this whole thing. So the main method is part of class Hello World, right? All of this code is part of the main, including this for loop, and this code is part of the while loop, which is part of the main, which is part of the class, right? That's why there's so many indents here. Because this is part of the while loop, which is part of the main, which is part of the class. So again, it will work, but I would highly recommend you use the indents between. It makes it a lot easier to read. Yeah, so this generally works. You have an error on line 34, which is why it's not compiling. You need to close your for loop. Close parentheses. And open and close curly brace. No, curly brace.
That again.
Yep. And then on 36, while should not be capitalized. And then you need a closed curly brace after line 38. No, just a close. You already have an open on line 36. You just never closed that one. Yeah, I would put that on a new line. So this is what I would call messy code. That up there is already pretty messy, but it's at least formatted correctly. So I'll help you fix this after we end the call. But I think this is good. Are there any more general questions? Lena? Cherry? If we are all set, then I'm... Oh, sorry, what?
I'm good.
Okay, in that case, I'm going to end the call or end the recording, and I will see you all next week.
Okay. Thank you.
Bye. How do I...
Have a good weekend.
Yeah, you as well. How do I end a recording here? Manage recording, stop recording.